Hey, what's up? Jason here from Unity3D.College. This video is going to be all about Raycasts and how you can use them in your Unity projects to make things happen. We'll talk about using them to detect line of sight, to detect clicks on objects if you want to have your user interacting or selecting them. You can also use them for bullet shots, gaze selection, and even UI highlighting, or like if you think about when you put the mouse over something, it's technically doing a raycast underneath, and you may have other situations where you want some interaction to appear when you put the cursor over it, or you're just looking at a thing. So let's get started. I've got a basic sample scene set up here, this Raycast basic, and in here we've got a cube and just a couple spheres. We've got 5 spheres actually, and if you look, they're just regular old spheres. In fact, if I just create another one, just go game object, 3D object and sphere. Now I've got sphere number 5 and reset the position. I can just move this and put it right into our scene, and it's going to work just like everything else. So you just have some regular old spheres and this cube. This cube, however, has a special script on it. This cube looking at spheres script. It's got 2 color options. Let's expand that out so you can see a little bit more. So it's a tint color and a tint color for Raycast All. You'll see what that is in a minute. And then a multiple checkbox. So let's hit play real quick. I want to show you what it does, and then I'll show you how the code works. So we hit play, it's facing in that direction. Look at the blue arrow, and you'll see that that arrow, or that sphere right there in front of the green one, or yeah, in front of it, turned green. So let's rotate it now. I'm going to select the cube and just go to the rotate tool, grab the little green spot, and just spin it around, and you'll see that, oh look, when it passes by them, it turns them green. There we go. Oh, that one didn't turn green. Let's see why. So let's aim it over there, and I bet if I go over here and look, you'll see that it's actually going right under, or right above this line right here that we're drawing. Now the line might not make sense, but if I take it and I tilt it down just a little bit, you'll see it's going into there. So kind of neat, kind of useful, but let's see what it's actually doing. Alright, here we are. So let's look at this script. We have our cube looking at spheres. It's a mono behavior because it's a game object component. We have 3 serialized fields here. These are serialized field attributes on private variables so that they'll show up in the inspector. We have a private color for the tint color, defaulting to green. The one for the tint for Raycast All, defaulting to yellow. And then this bool, which just defaults to false because it's a bool with no default value set. Then in our update, we just check to see if this multiple checkbox is checked, and if we do, if it is checked, we go into this Raycast multiple call. If it's not checked, which is what we were just seeing, we just go into this Raycast single call, and this is what I want to take a look at. So let's zoom this in a bit. Raycast single here. Let's even collapse some of this stuff out of the way. So the first thing that we're doing in here is getting the origin for array. Now array is just a point and a direction and a magnitude. It's essentially a line that we're casting into the world, or from inside the world even, to find objects that intersect with it. So it's like we're taking a line or a laser pointer and shooting it straight ahead and seeing what it's going to hit. Now with the ray is that line, or that laser pointer line. The Raycast call actually happens down here on line 28. But first we need to initialize our ray, or our line, and that's done right here on line 26. Now this is not the only way to do it. You can do a Raycast by passing in an origin and a direction into this Physics.Raycast, but we're not doing it that way. Instead, I like to do it this way, where I create the ray, and a ray takes, well here, let's just look at the options here, takes an origin and a direction, or nothing. So we give it the origin, this is just the starting point, and the direction that it's going to go in. Now the red line that we were seeing is actually done a bit above that, right here on line 25. We're doing debug.drawRay, and here we have to actually give it an origin, we have to give it a direction, but notice this times 10. And this is actually the magnitude, because when we use draw ray, it wants the direction to be a direction with a magnitude on it. So imagine if we had like vector 3.right, it's got the 1 on the x, this would be a 10 on the x instead. So, or like a 1 on the y if we were going up with vector 3.up, and then we'd multiply by 10 to go up 10 meters instead of 1 meter. So this distance right here is just controlling how far out that ray draws. Let's look at it again real quick. I just want to make sure that that point sticks, because this can be a little bit confusing. So let's see. Let's hit play. We've got the ray drawing right there. You can see it's going out to about there. And I'm going to go back into the code, and I'm just going to turn that down to like a 5. No, in fact, let's turn it down to a 2. And then let's go back into game. Just let it recompile. Shouldn't even have to restart it. And you see that the line is now right out to here. But watch this. This is kind of the important part. I'm still in rotate mode here. I'm going to grab the green line and spin it. And it's still turning them green. Right? The red line isn't reaching them, but they're still turning green. The raycast is still hitting. Remember, this is the one that's, I think, tilted. Yeah, that was the tilted odd one. So why is that happening? Well, let's take another quick look. And remember that line 25, this is just a debug call. This is only done in the editor, and it's just for us to see where we're drawing our ray or where we're creating our ray. So the distance here is just how long that line is going to be. It's not the distance of the raycast. In fact, if we get down to the actual raycast now on line 28, we're not giving this a distance at all. When we give it a ray here with Physics.Raycast, it doesn't care about the magnitude of this vector. It just wants us to pass in the raycast and then give it an optional max distance. So if you look right here, I hit the comma there, a max distance appeared. By default, this is going to be infinity. So your ray is going to shoot off forever all the way into your world until it hits something. And it's going to return back out the first thing that it hits in this variable right here, this raycast hit variable. So we call if Physics.Raycast. This is going to return a true if it does hit something, false if it doesn't. We pass in the ray, and then we get out this raycast hit. Now this is kind of all collapsed into an if statement. Another way to write this would be something like, well, we could go raycast hit info, like that. And then we can do bool result equals Physics.Raycast, and then give it our ray. And then we could give it a max distance, but I like to go down and just go down to the hit info. But let's say we wanted to only go out 5 meters. Let's do that, in fact. We'll go to 5, so we're on this overload right now. Then hit comma, and see the overload is updating again. It's really important when you're going through these two to make sure that you're on the correct version of the call. There are a lot of different versions of this call that will implicitly take things, like you maybe pass in an accidentally pass in a layer mask for a max distance or something, and it's very, very easy to mess those up. So make sure that when you're going through, you're looking at the IntelliSense here that's popping up and selecting the correct thing. So here we've got a max distance of 5. In fact, let's turn this into a variable. Float max distance equals 5. And I'm going to cut that and just pull it right up here, because then we can put it into our drawn ray as well. So we've given it a max distance of 5. And then we need a layer mask optionally. We're not doing that yet. So let's find the one that has a hit info. Oh, look, if I go down to 6, you'll see, oh, look, raycast hit actually comes before max distance. So I have to go over here and go out hit info. So this would do essentially the same thing, but it's going to give me the result in this bool. And then I could say if the result is true, like this, if result. Then we would call the code that gets the renderer and changes the color. It's giving an error message here because I renamed this to hit info. If I went like that, we'd be fine as well. So I'll just leave it like this. This is fine. Oops, didn't mean to hit select all. But I want to, well, talk about the other option here, this Raycast multiple and how this works. Before I go on though, I want to show something that I had in the other version that's not here anymore. And that's that with the latest versions of C# and Unity, we can actually declare this hit info right here. This out hit info, or out raycast hit info. In fact, I'm going to rename this hit info back to raycast hit, so that the name matches. But I wanted to point this out. If you can't do this, you get an error with this. You're just on an older version of C#, an older version of Unity. You either need to upgrade or just declare it up before the call to Physics.Raycast. So that's how the whole thing works. We raycast, we see if we hit something. If we did, we get the thing that we hit right here in this raycast hit. We get its collider, and then we get the renderer component of that object. So we hit a sphere. Let's select a sphere. We get back the collider right here, and then we call get component to get the renderer, which is giving us this renderer. On the renderer, we're looking at the main material, so that's going to be this material right here, which is just a default material. And then we're setting the color to whatever the color is on our cube, or whatever the color our cube is set to do. So what does the multiple one look like? Let's take a look at the code before we actually run it. Raycast multiple. Again, we're just caching the origin and direction right above. Now we don't have to do these. We could put transform.position here, transform.direction there, but since we're putting it in multiple places and it's a little bit easier to read, I wanted to split that out. So here again, we're drawing a ray 10 meters out. We're just doing it in yellow so that we know we're in that other mode. We're creating our ray. Then we call this var multiple hits equals Physics.Raycastall, and I pass in a ray. It's a little bit different, right? We're actually not getting back a Boolean. We're getting back an array of raycast hits. So the difference here is that Raycast All won't stop on the first object. It'll actually go all the way through. It'll return everything that your raycast would hit. In here, once we've got that, we loop through the hits. We get the collider, get the renderer component, and set the color to this other tint color. Let's see it in action real quick. So I'm going to hit play. I'm going to turn and face it at these two spheres right here. So just turn it over and face it right at them. You see that only that one is green. In fact, if I, let's take this one and duplicate it. Hit W, and I'm going to move it right out in front. And you see that now that one's green. The other one didn't turn white again because we're not turning them back to white. We just leave them as the color that we change them to. But notice that this back one is never changing. That's fine. It's because it's getting blocked by these other ones. But if we hit multiple, bam, goes all the way through. You may notice that they also all changed to yellow. And that's because, remember, this raycast hit is being successful on every one of these spheres. It's finding all of the spheres in the code. I'll go back to that code real quick. Right here, this Raycast All is returning back a hidden or a raycast hit object for all of the colliders. We're looping through them and turning them yellow. So pretty simple, right? There's not a lot to it. And if we want to change the color here, whatever, we'll change it to a red and maybe even move this thing around. You can see it's just wherever that raycast is going, that's where we're hitting things. So kind of cool, but there's more to it. There's a lot more to raycasting than just creating one off of an object and facing forward. The most common use, in fact, is to raycast directly into a scene. And I have this game object here called Raycast into Scene, and I want to show you what it does. Let's hit play. And watch. I'm just moving my mouse. I have the game view selected, so I've clicked in here. Just move my mouse over these things, and they turn green. They're touched. They get touched, basically, and they turn. So what's happening? Well, we're essentially doing the same thing, but we're not raycasting from this object. Instead, we're raycasting from the camera. Where's our camera at? Our camera is up there. So we're actually shooting a ray into the world from our camera. Let's look at the code, and then we'll add some debugging so we can see it a little bit better. So our raycast into scene script is just another mono behavior because it's a component on a game object. And we have a serialized field for a camera. If we go look at that, you'll see that our camera is just set to this main camera. Now I didn't set that manually. Instead, I did that with onValidate. So in onValidate, we check to see if the camera is null. If it is, I just set it to camera.main. The point here is to show that we don't have to just use camera.main to look at it or to grab a ray into the scene. A lot of the time we want to cache our main camera or cache whatever camera the player is using. So we can do that with the serialized field or with some call that grabs it or whatever it is. But you just need to know what camera the players are actually using if you want to handle these click events. So to make it work, you see there's not much code. In our update, we get the mouse position. So this is just input.mouse position. I'm just caching it into a vector2. Kind of an unnecessary step, but again, make it really clear what's going on. Then we create a ray, and we use camera.screenPointToRay. And this is just a method on the camera. You can see it right there. It returns back a ray, takes in a vector3. But actually what it takes in is a vector2. We give it a vector2, not a vector3. That gives us a ray. We do the raycast, and if we hit something, again, it goes into this raycast hit, we turn it green. Kind of cool, but let's add that debug. Let's add the ray so we can actually see what it's doing and see how that ray is working. So we'll do debug.drawArray, and we'll go at the origin. So that's just going to be, well, our camera position. Oh, camera.transform.position. And then, well, we would have to figure out the direction, right? So this is not actually how we do it. Instead, if you look here, remember we have an origin, we have a direction, we have this ray right here. So we just do ray.origin, ray.direction. Now don't get me wrong, I've gotten myself confused in the past, and I used to try to figure that out, and then I realized, hey, it's all on the ray, it's all here. These methods exist for a reason because they're things that we need to do often. So now I remember when I'm doing my draw ray, I need to give it a distance. So I'm going to give it like a 10 again. And then I want to give it a color. So I'll do color dot, let's go with green since I'm making them all green. So save, jump back over to the editor real quick. And I'm going to restart because these have already all turned green. And what I want to look at, though, is the ray coming from the camera. Look at that. You can see the ray coming into the world from the camera. And I go down and touch this thing right here. And you can't really see it hitting, can you? Oh, let's go down. Let's get right down here, and I'll put my mouse right around this thing. And notice it's not actually touching. Remember, the thing here is that the ray distance that we're drawing is totally defined by this multiplier right here. Our raycast is infinite. So let's just turn this up to like mathf.infinity. We'll draw it all the way into the game. So it'll go on forever. Kind of like our real raycast is. All right, there we go. We're in, and where's our ray? Well, do you see it? Anybody see the ray? No, we don't see it because we set it to infinity. So let's go back and turn that down a little bit. So we'll go down to maybe like something more realistic, something that we actually want to draw, because we can't realistically draw a line that goes forever. Think about it for a moment. Like, how does the engine draw a line that goes forever? It has to end somewhere. So we just make it end at 20 meters. Seems fine. But I wanted to point that out because if you do use infinity, you're not going to get anything. But there, now we can see that the thing is going there. It's kind of going around. In fact, if I go up above, you should see that I'm kind of circling around the guy. There we go. It's going behind and in front. And if I touch, it lights up. Perfect. So this is how we do things like clicking on objects. If we want to do a raycast into a scene to detect an object, click, we could do it just that way. But there are times when we only want to be able to interact with specific objects. And we could do some checking in our code. Say, hey, is this a sphere? Is this a cube? Is this whatever, a user interactable thing? Is it maybe like a UI element or something like that? But we can actually kind of bypass that and filter these things a little bit faster in our raycast. And we do that, well, with a slightly different version of the script. We'll go into our raycast layers scene because we're going to use layers. We use physics layers in our raycasts to filter things out. So let's hit play on this one. Notice that I've got some cylinders now. I grab my cube here and look at this layer mask option. It's set to cylinders. I'm going to rotate my cube. Notice that nothing's turning, nothing's changing colors except for that cylinder. In fact, the two cylinders that are there. There was one that was being faced right from the start, turned green, and then the other one when I rotated towards it. Kind of cool. What if I select this layer mask and just change it to, I don't know, everything? Oh, now you see that the spheres are getting changed. What if I stop and I change this to default? So I want to uncheck cylinders and just check default. I hit play. And now we should see that cylinders don't change. But hey, maybe the cylinders aren't changing because multiple's not on. Let's turn multiple on. Nope. You see that? It's still not going through, or it's going, I guess, right through this cylinder and hitting both of those spheres. Now, how does this work? How do we use a layer mask? Well, the first thing that you need to do is put your objects onto actual layers that make sense. Usually these layers are split up by use case, or like what the object is going to do. If it's an interactable object that players are going to use all the time, it'll probably be on some sort of an interactable layer. If it's a UI thing, it may be on a UI layer. If it's a pickup item, it could be on a pickup layer. If it's an NPC, it could be on an NPC layer. Here we have cylinders, so they're on a cylinder layer. Kind of boring, right? Let's make something a little bit different though. Let's go into game object and let's bump it up, and we'll make capsules. Really fancy, right? Reset this guy up, and now we've got a capsule right here. And I want to get this kind of lined up with the rest of these, and I want to give this a layer. So if I went to layers, you'd see I have a cylinders option. I have all of these default ones, but I don't have one for capsules. So I go to add layer and type in capsules. Just give it layer 10. I usually just go in order for these layers as long as they're available. And I select my object, and you'll see that, oh, I selected the wrong one. Select the capsule. You see it's still on the default layer. It's because when we add a new layer, it doesn't actually change it. So we have to go back, select the object again, and change it to the capsule layer. Now, if I hit play, well, my cube is still hitting default only, right? It's set to default. I can rotate it over here. It's just hitting the default objects. But now on my layer mask, capsules is an option because this is automatically populated by our project layer. So if I hit that, well, still didn't hit it because we're hitting the spheres. So if I uncheck default though, then we're getting it, because now I'm only hitting capsules and I'm going all the way through. In fact, if I hit multiple, you'll see that only the capsules get turned yellow, or the one capsule. And if I start adding things like cylinders, now it's being hit, and I can add default, which is what the spheres are on, that default layer. So same kind of thing, but we can filter these out. Now let me show you how that code works. You'll be amazed. Now to get the drop down for the layer mask, we add a type of layer mask and just use that serialized field attribute to make it show up in the inspector. We could again alternatively make these public, but if we don't need our variables to be public, it's generally better practice to keep them private and add the serialized field attribute so that no code accidentally changes them and breaks things. And it also makes it a little bit easier to understand how to use your code. So let's look at it again. If we go into this Raycast single, you'll see here, first thing I've done is turn the max distance right here into a constant. If we go up to the top, that's our constant max distance. It's just to make it a little more obvious. In fact, I should have pasted that right there as well. So we do the same thing. We get the origin direction, we draw the ray, we create the ray. We have a comment here for an error that I'll show you in just a moment. And then we do this raycast, but here we're passing in a layer mask. So if you look, well, we're not even showing the correct rate. Let's see, where's the one that we're using? We're using this overload right here. We have a ray, we have an out raycast hit, we have a max distance, which is a float, and then we have an int layer mask. You might be wondering, hey, that says int and this says layer mask. Layer mask actually derives from integer, so it goes in there perfectly and it works. You can alternatively do the math to figure out the number that goes there for your layer mask, but just using the drop down works 90% of the time. So what's the error then up here? What's this issue? Oh, let's comment this one out and comment this one, or uncomment this one so that it comes in. And I could even play. We'll see. It's not going to work. It's going to work a little bit weird at least. So here we go. We're in. Seeing like, hey, what's going on? Why are these not changing? Oh, what if maybe I'll change the layer mask, right? Let's change this to everything. Oh, did I do anything? No. Well, let's change it to just cylinders. Hey, that's weird. I unchecked cylinders and spheres started working. Let's uncheck default. I don't know. Just pick some random stuff. Oh, you get the idea. It's definitely not working as it's supposed to, right? But let's look at the code again. It's compiling. Why isn't it working? The problem, again, hopefully you didn't see the little tooltip there. In fact, I'm going to cut that and move it right up here. It's that this, while it looks right, this Physics.Raycast, giving it a ray, or giving it the hit out, or the raycast hit out, and we're giving it a layer mask. It looks good. It has no errors. It seems like it's working. But let me hit backspace and hit that comma. Notice that that doesn't match our overload at all, right? We're not using that because we have an out hit info. So that's wrong. Which one are we actually using? Oh, look. The one that takes a ray, a hit info out as the second parameter, and a number out, or number in, which is a float for max distance, is actually this one. So it's misreading our layer mask. Since an int can convert over to a float, it's thinking that we want to use this one, and it's giving us our layer mask for the max distance. So we're not getting a mask. In fact, we're just getting a number that doesn't make a lot of sense because it's a bit masked number as our max distance. So that's why a lot of values are negative or 0, so it goes down, and then when we pick those other ones, the number gets big and suddenly we hit things. So I really wanted to point this out because it's a mistake that a lot of people make. People get stuck with it for hours on end. I've done it myself, like wasted a day trying to figure out what was wrong, not realizing it was a tiny little mistake that's really easy to overlook in this raycast call. Now our raycast multiple thing here, exactly the same. The same with raycasting into a scene. If we want, we can do the same thing where we just add in a layer mask. We just add it onto our raycast call and it would all work. So again, these are really useful for all sorts of game development. They're extremely fast, so don't worry about like, hey, am I killing the game performance by doing some raycasts? That's what they're there for. They're there to find objects quickly that use the physics system, that have colliders. So if you need to do that, shoot out some raycasts. If you need to shoot out a bunch of them in a frame, don't worry about it until it becomes a performance issue that really shows up on your profiler. I wouldn't worry about it at all. In fact, general typical line of sight system, we'll be shooting out a bunch of different raycasts all around to see like if an enemy can see things. So you can imagine that these are relatively lightweight and very fast. Again, very useful. All kinds of different things that you can use them for. And don't forget about creating rays with cameras. There are actually a couple other ways that you can do that. Maybe I'll talk about them later if people are interested more in raycasting. Anyway, I hope this is helpful. If you have questions about raycasting, just drop them in a comment below. I'll try to read them and get back to them. And don't forget to like, subscribe, and share with your friends. And just let me know what other kind of content you're interested in. All right, thanks again, and goodbye.